advanced pre-calculus, we're going to start our transformations. So this is the pages following our development of sine and cosine. Okay, and so let's do some basic transformations. Okay, so right here, if you look at here, we have a vertical stretch as we go from f of t to g of t, a vertical stretch by a factor of 2. Okay, so that's your transformation is the same as that you would have on a polynomial. All right, so we're going to do our big 5 points here. These are your quadrantals. So 0 to 2 pi, half it, quarter it, easy. And cosine starts high and ends high. So the max, equilibrium line, minimum, equilibrium line, max. So let's just graph that real quick. All right. So this is just cosine, nothing, just easier than the other page because the other page we did all the values. But basically when you graph like on those worksheets, you just do these 5. And it does say to just go 0 to 2 pi. So go like that. All right. So now we're going to graph the stretch. So a vertical stretch is going to stretch, I'm looking for a different pen color. Vertical stretch is going to stretch the y. So this is your x value, this is your y value. So there's no transformation on the x value. So we're just going to have a transformation on the y value. So I'm going to graph this line for sure, and these are just going to be, times 2. So this will be 2. 0 times 2 is still 0, negative 2, 0, 2. All right? So now the graph's just going to go up to 2 and down to negative 2. Okay, so it'll start high. My red pen is not working. Let's see what else here. Hold, please. Hold, please. Yeah. Okay, so here, 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 and here. Okay, so it's just been stretched by a factor of 2. Okay, so let's do our next one. Sine, big 5. And let's see what's happened here. Right. So we have a vertical reflection over the x-axis and a vertical shift up 1. Okay, so sine starts at the equilibrium, goes up, equilibrium goes down, equilibrium. So you want to make sure you do the shifts last. Okay, so you want to make sure these are both vertical, so they're going to affect the y value. So this x is set, and now the y is going to get transformed. So negate, 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 negate. So that's times by negative 1. Times, that's not an x, that's times. And then plus 1, add 1. So 1, 0, 1, 2, 1. Okay, so notice there's a new equilibrium. Line at y equal to 1. So I like to put that on here just to kind of guide my sine graph or my cosine graph, because that's what it's going to weave around. So sine is going to start on the equilibrium line. Usually goes high, but now it's going low because it's been vertically reflected. And there you go. So there is that graph. Okay, and if we had done regular sine, regular sine would have I'll reverse the colors. Okay, so this one, this blue here is your parent function cosine. This pink here is 2 cosine of t. Now here I did the transformed one in blue. I didn't do the parent one first, sorry, but if you were to just plot the regular old sine, it would go like this. So that pink is just the parent function. So this right here is y equals sine of t, the parent. So you can see that it got reflected and then pushed up. Okay, deflected and pushed up. Okay. Definition of amplitude. Okay, this is really, 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 really easy. Definition of amplitude. Okay. The amplitude is just how high and how low the graph goes from the equilibrium. So here's the equilibrium. So sine goes up 1, it goes down 1 from the equilibrium line. So that's an amplitude of 1. Here it goes to -2 amplitude. Amplitude means height, and you're not doing the total distance of 4. You're just doing from the equilibrium line. So that's a distance of 2. That's a distance of 2. Amplitude's always positive. Okay, and so both of these have an amplitude of 1. From the equilibrium line, this traveled up 1 and down 1, and regular old sine travels up 1 and down 1. So this is going to make it sound more complicated than it is. The definition formally of amplitude is 1/2 the absolute max value and the absolute min value. Okay, and so you minus those two, which means you end up doing the opposite of the negative one. But if they're all above if you got a vertical shift where everybody's above the x-axis, then this really works. So the amplitude of y equals to 2 sine. You guys, it's 2. Newsflash, it's 2. Over here, it's 1. You just look for this value, this stretch value here. The shift has nothing to do with the amplitude. It's just that stretch, or we'll get to some compressions value. But let's go through. So this would reach up to 2 and down to 2. And so if you have kind of a theoretical question, this can help you. 2 minus -2 equals 1/2 4, which is 2. So, if you had some like variables involved and it wasn't just common sense, then you can use that formal definition to help you. All right. So here, this is just 1. But if we go through the motions, the regular absolute max of sine is 1. The regular absolute min on the parent functions here. This gets a vertical shift of 2 by that plus 2. So, it's going to matter as I do the formal definition, but you'll see at the end that this doesn't even matter. So this is 3, this is 1. So by the formula, 1/2 of 3 minus 1 is 1/2 of 2, which is 1. It's just that number right there. So in general, the amplitude of the function here is the absolute value of A. It's just that number in front. Use the definition of amplitude to find the amplitude of the following, okay? And so on this one, let's change up. I mean, this is the definition. This is really, in general, the definition. You could go here or here. Let's just say the amplitude is absolute value of 40. Boom, done. All right, and so predict the maximum minimum output value. So max value, these are your y values. Okay, so this is going to be a shift right 6. So in terms of max and min y values, I don't care about that 6. So the max is going to be 40, and the y is going to be -40. The max is going to be 40, max y is going to be 40, and the min y is going to be -40. Max y 40, min y -40. Okay. Here again, A is absolute value of pi. Okay, and so that's just pi. Pi is a positive number, and so the max here is going to be at 5, and the min is going to be at -5, but it's going to pi and pi. I've already got my head around the shift. Pi and negative pi, and it's going to incur this vertical shift of plus 5. So the max is going to be pi plus 5 and the negative pi plus 5. All right. So you want to assess the amplitude first. You know, assess the height, and then apply the vertical shift always last. All right. So next page. Okay, we've got our first horizontal. Okay, so this is happening in the parenthesis. So this is a horizontal. You guys remember this? And it's going to flip 1/2. And when it's 1/2, that's a compression. Horizontal compression by a factor of 1/2. All right, so watch what this does. Okay, so the basic cosine graph takes 2 pi to make a complete cycle. What will you need for 2t, cosine of 2t, to make a complete cycle? Well, it's going to get compressed by 1/2. So the cycle would be complete at pi. Okay, so here's your normal cosine. Starts high, high equilibrium, low equilibrium here. Now what happens if I compress it? So this is a horizontal. So now I'm going 0 to pi. So I want to split it, quarter it, and 3/4 it. There's been no vertical shift here, so these don't change. Okay, so let's put these values in. Pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, going all the way to 2 pi here, 3 pi over 2, 7 pi over 4. Okay, so I put in the big 5 right here, so let's graph cosine. Here's cosine, normal. So now what happens when it gets compressed, it's just going to be squeezed in. So now we're still are going to start high, but then we'll go to the equilibrium at pi over 4. And complete the cycle like that. So this is the pink is y equals compressed. The cycle is done in half the time, basically. Okay. Some observations. The transformation from y cosine t to y cosine 2t is a horizontal compression. We've already said that. By 1/2. The original period is 2 pi, which means 2 pi times 1/2 is pi. That's the period for cosine 2 pi. All right, so in general, B is this number in the parentheses. Okay, so amplitude we call A. It's out here. Okay, that's amplitude. Excuse me. Amplitude is outside, right? And then the B, we call B the one that's in the parentheses. So this is your horizontal stretch or compression. And to figure that out for sine and cosine, basically you take 2 pi over the B value. This is important. 2 pi over B. All right, so apply what you know. Let's do sine. Okay, I'll do sine here in blue. 0, 1, 0, -1, 0. So this is going to be a stretch. So I'm just going to go pi over 2 pi, 3 pi over 2, 2 pi. Okay, there's sine. Good old basic sine. And now this has incurred a horizontal. Remember, horizontals do the opposite. So 1/2, we flip it. If it's added, you subtract it. If it's subtracted, you add it, meaning if it's added, you go left. If it's subtracted, you go right. So if it's 1/2, you go times 2. If it's 2, you go times half. So that's a stretch. Okay, so that means 2 pi is going to be divided by b, but basically it's going to be, or you can think of it as 2 pi times 2. Our period here is 4 pi, which is the same as 2 pi times 2 over 1, 4 pi. All right, so 0, 4 pi, 2 pi, so that's just pi, and that's just 3 pi. 0 up, 0 down, 0 is how sine fluctuates. So pink pen. So now I'm going to go here. We're going to extend this. Okay, so we would go from 2 pi and 3 pi here and 4 pi here. So now we're going to start. Go high. Equilibrium. Go low and back. So that has been stretched by a factor of horizontally stretched by a factor of 2. Okay? So that period was 4 pi. Okay, last page. You can just imagine that blue stretching. Okay, so just some more graphs here. All right, so we got a lot of stuff going on. The amplitude right here, that's 1.5. Period is 2 pi over b, so 2 pi over 2 pi, which is 1. Okay, so amplitude is just the absolute value of this number. And okay, sorry, the amplitude is just this number, and then the period, you take this number in front of the angle, which is t, and just go 2 pi over b. Okay? All right, so let's just graph this. So we always start with the basic. So these are your x's and these are your y's, right? So just look, this is cosine. Okay, so we're going to go 2 pi, sine and cosine do the same. Okay, and then cosine goes high, equilibrium low, equilibrium high. All right, so let's transform 2 pi over t. So instead of going from 0 to 2 pi, now we're going to go from 0 to 1. So half it, quarter it, 3/4. So this is going to be 1, 1/2, 1/4, 3/4. Okay, so we're graphing. This is the transformed versus now our amplitude. Okay, so we have a vertical reflection and a amplitude of a stretch. So this is, we're going to just multiply that. That's going to be negative 1.5, 0, positive 1.5, 0, and negative 1.5. Okay, so we're going to be graphing these two. Alrighty, so we've got 1.5 and negative 1.5, and so let's do it. 0, cosine, like that. This stuff is really kind of easy if you can just you know, just learn the new material and embrace it. It's really not that bad. All right, so there's that one. Let's do this next one, and then I may have to stop. Let's see what time it is. Okay. Okay, lots going on here. Let's start with our amplitude is 3, easy. Let's start with our, now do our period, so 2 pi over 1/4, which is 2 pi, I'm sorry, it's 8 pi. And then I got this vertical stretch to deal with. So these are my x values here, and these are all my y's. So normal sine, oh, sorry, period, 8 pi. So normal sine goes like so. But when I have this 8 pi, right, this 1/4 t, it doesn't really matter what you write here. We're going to go all the way to 8 pi. Half it, quarter it, 3/4 it. Okay, so the big 5 here go to 8 pi, 6 pi, 2 pi, 4 pi. All right, normal sine starts at the equilibrium, goes up, equilibrium goes down, equilibrium. But now I'm going to put an amplitude on it. 3, 0, 3, 0, negative 3, 0. So that's a times 3. And then I'm going to do this vertical shift down 2. So negative 2, 1, negative 2, negative 5, negative 2. So my equilibrium line, which I highly recommend putting in, is here, y equal negative 2. Okay, so it's going to, the max it's going to reach is this 1, and the min it's going to reach is 1, 1, 2, 3, 4, 5. Okay, so equilibrium line, notice 1, 2, 3 spots up, 1, 2, 3 spots down, amplitude 3. So that is all good. All right, so I am graphing this line versus this line. All right, not versus, but in correlation with. So 0, this is sine, right? Sine starts at the equilibrium, and it's going to be heading up to this max, back, min, and back. So this equilibrium line helps because people are always drawn to that t-axis, okay? So this just looks like this. Okay, switch the prompt. I'm going to kind of jam through this. Write the equation of a cosine function with amplitude 3, root 3, and period 4 pi. Okay, so if 2 pi over b is 4 pi, there's the period formula and that. All right, so then 2 pi equals b times 4 pi. So 2 pi over 4 pi is b, just basic algebra. B is 1/2. All right, so y equals amplitude, root 3. This is cosine. And then this is going to be 1/2 t. All right. Okay, amplitude here is 1/5, easy. And period is 6. So 2 pi over b equals 6. 6 cross multiply, 6b equals 2 pi. b equals 2 pi over 6. b is pi over 3. b is pi over 3. All right? So we're going to just throw that in there. Okay, and so one thing I want to note here, this is kind of the obvious thing your brain's going to want to do, but, you know, remember this is the absolute value. So technically this could be plus or minus. So you want to put in plus or minus. So that's going to be important. That'll be worth half a point on a test if you don't do the plus or minus. So make sure you get the plus or minus in there. The only way to eliminate the plus or the minus is to actually see the shape of the graph and see that starts high, that starts high. This starts at the equilibrium and goes low. And so that way you can actually get the correct, plus or minus when you actually have a visual. But these are pretty general, so you have to include that plus or minus. Okay, I got to go pick up my kids, so I'm going to end this 6.4 video here and do these ones later. So I'll try to talk about that in my title, try to reference that correctly. Okay, good stuff. All right, we'll see you in class, guys. Bye.